Hi, NTeamEN, Nicholas speaking, and today we're going to talk about gravity. Gravity is one of the fundamental forces of physics that causes the attraction with equal forces of two objects with mass because of that mass. Actually, no, it's not between two objects with mass but two things with energy. This is why things like light that have no mass but have energy are attracted by gravity, but in this video I will simplify by saying mass instead of energy. The idea that the attraction between two objects is mutual and equal is very important. Indeed, if we take two objects like the Earth and you both attract each other with the same force. And right now you might say, but Nicholas, why is it that when I jump I'm the only one to move and the Earth doesn't move? Here is an example for you. What you saw was the Earth and I attracting each other with the same force, but it takes more force to move the Earth than it takes to move me, so I'm the one moving the more. And that's due to the fact that the formula to calculate the force that attracts the Earth and me is this one. But the most important part of this formula is the denominator, and here is what we can see. If the two objects have mass, then no matter the distance between the two, the force will never be zero. This means that no matter the distance between two objects, they will always be attracted by gravity, but I'll talk about this later in this video. One last thing to know about gravity is that it is a force that always attracts things, it never repels things. Now we're gonna see what is the role of gravity, and it's not just to keep us from floating in space. Gravity made possible the formation of galaxies, stars, planets, atmospheres. In other words, without gravity there is no life. Now that we have seen that gravity is important, we're going to see some misconceptions about it. So the first misconception is that there is no gravity in space, and of course it's not true. At the contrary, since gravitational attraction has no limit of distance, there is plenty of gravity in space. Now I'm gonna say something that might surprise you. Right now your body is attracting all the atoms in the universe and they are attracting you as well. For another example, let's take astronauts. Right now they are undergoing about the same gravitational attraction as we are. It's just that they are falling at the same speed as they are getting away from the Earth, so they are in orbit. The second misconception is that we can escape the gravity of a planet. And no, it's impossible since gravity has no limit of distance. By the way, do you remember when I said that to calculate the force of attraction between two objects it was this formula? Well, I lied. Actually, this was the formula discovered by Isaac Newton between the years 1665 and 1685. And this formula functions for things that are going at somewhat small speeds like us. But for things going at speeds close to the speed of light, this formula is not the right one anymore, and we use Albert Einstein's general relativity. Between 1907 and 1915, Einstein elaborated the theory of general relativity, which gave us a new concept of time and space being the same thing that is stretched by gravity. Time is influenced by gravity in such a way that the more massive an object is, the more it slows down time. So, if you are in orbit around the black hole at the center of the galaxy, just because of gravity, time will be twice slower than on Earth. If you listen during this video, you've learned what is gravity and its role in the universe, and you've stopped believing in two misconceptions. And now you also know that gravity is a force with an unlimited range, but it's the weakest fundamental force of physics, and we will talk about the other ones in the next weeks. Alright, we're done. I'll see you next week.